Okay, section 8.2, solving systems of equations algebraically. Okay, we're going to go back to grade 10 and look at the two different algebraic methods we use to solve systems of linear equations. So I don't know if you remember, but one of the ways was called substitution. And the idea here is you want to take one of the variables and solve for it. So you can either solve for x or solve for y, and then substitute that equation into the other one. A lot of times what I like to do is label the equations number 1, number 2. And in this method, I'm going to solve for one of the variables. I'm going to take number 2. I'm going to actually solve for x. Now, of course, I could take number 1 and solve for y, but don't like that negative stuff, so I'm going to solve for x instead. Bring that 3y to the other side, you get x equals to 3y plus 5. Okay. Then take this and now substitute it. That's why it's called the substitution method, into equation number 1. So wherever I see x, I'm going to replace it with 3y plus 5. And as we go ahead and try to solve, let's distribute. That's 6y plus 10 minus y equals to 5. 5y equals to, I guess, negative 5. Y equals to negative 1. Okay? Now don't forget, you're supposed to solve the system of equations, so you need to solve also for x. Plug it back in and solve for x, so x equals to 3 times negative 1 plus 5. Negative 3 plus 5, that's 2. And in grade 10, we wrote it as a coordinate, 2 comma negative 1. Okay? Anyone remember what the other method was called? If you said elimination, you are correct. Now, elimination asks you to either add or subtract an equation. So you can only do that when the coefficients of one of the variables are the same. Now, if you look at my two equations, I'm going to write them again. 2x minus y equals to 5. X minus 3y equals to 5. The x's, well, the coefficients are the same. The y's, the coefficients are the same. So you have choice. Either make the x the same or make y the same. You choose. I'm going to choose to make x the same. So I'm going to call this 2x minus y equals to 5. No change. But what I'd like to do is multiply every single term in the second equation by 2. And when you do that, you get 2x minus 6y equals to 10. Go ahead and subtract now. So 2x minus 2x is 0. Be careful here, negative y, take away negative 6y, that's just positive 5y. And 5 take away 10 is negative 5. Notice we get the same thing as before. We'll solve for y, y equals negative 1. Okay? Don't forget to plug it back in. So plug back in to solve for x. And we've done this already, so I don't want to do this again. But you'll get the same answer as before. X is 2, so the answer is 2 comma negative 1. Okay, that was a review of grade 10. Now in grade 11, we're dealing questions that are more complicated, like the ones we did last time, linear quadratics and quadratic systems of equations. So I'd like us to take a look at this example now, and I'm going to ask you to solve this system of linear quadratic equations algebraically, using both methods. So first of all, I'll use substitution. Any suggestions on which one to use? Some of you are saying solve for x for number 2. Okay, I will do that. And then now substitute this back into number 1. Okay, so let's keep going. We'll substitute and solve. So wherever you see x in number 1, replace it with 4y plus 1. Okay, now go ahead and solve this. So expanding this out, be careful. Don't forget it's a plus b all squared. You have a middle term. A lot of people forget that. Distribute. Okay, I will now simplify. 8y is negative 20. That's negative 12. Whoa, negative 13. Numbers don't look good. 1 plus 4 is 5. Minus 5 is 0. Not too bad. Okay, now in this case you want to solve, I'll factor out the y, so you get 16y minus 13. And yeah, one of them's bad, but one of them's pretty good. Y equals to 0, y equals to, in this case, I think 13 over 16. Okay? Well, if y is 0, we go back and try to solve for x. So I plug it into equation 2 again. So x equals to 4 times 0 plus 1. X equals to 1. Plug this in. 4 times 13 over 16 plus 1. Well, that's the same thing when I simplify to become 13 over 4 plus 1. That's 17 over 4. So I guess the other answer would be 17 over 4, comma 13 over 16. And this one over here is just 1, comma 0. Your two solutions. I'm going to ask you to try to do the same thing now with elimination, all right? Same question, different method. Let's eliminate. So in this case, you see how there's an x squared and an x term in the first one, and there's only an x in the second one? Well, in this case, I would not eliminate the x terms, okay, because you're still going to have an x squared. I'd eliminate the y's, because that's just by itself, it's singular, okay? So I would take equation number 1, and I would actually multiply that by 4, because if I multiply it by 4, look what happens to the y. I get now minus 4y plus 16 equals to 0. And that's nice because look what I have here, x minus 4y, and I'll bring over the 1, minus 1 equals to 0. And in this case, should I add or subtract when the signs are the same? When the signs are the same, you should always subtract. So take the green equation, subtract the blue equation. So 4x squared, and then you have minus 21x. The negative 4y, take away negative 4y is 0. And then 16, and then plus 1, I guess that's 17. Okay, and this equals to 0. Then go ahead and either factor or quadratic formula. I will factor in this case 4x, I believe, and x, and then 17 and a 1, I believe. Yeah. So in this case, you get x equals to 17 over 4, and x equals to 1. Similarly, I can plug it back in, solve for y. Y equals to, oops, y is not 0. What is y? I'm too lazy to do it. I'm just going to copy the 1 from over there. By the way, if you're not that lazy, you should plug it back into the blue equation. I think that's the easier one. And you'd find out the y values as well. Okay? But because the question's the same as what we did to the left, I don't want to do this again. Me being lazy. Okay? Same. Alright, well that's the general idea. So if you get that idea, then you're all set. Why don't you try the next question here? Now for this one, notice that you actually don't have the equations. So what I'm going to ask you to do is actually find the equation first, and then use whichever method you like to solve. Okay? I don't know if you like substitution or elimination, you choose. But before we do that, let's find the equations. It says here, find the dimensions of a rectangle if its diagonal is 17 and its perimeter is 46. So let's draw a rectangle. When I talk about the diagonal, I'm going from one corner to the next, and that distance is 17. The perimeter here seems to be 46, so if I use L and W's, I guess 2 L's plus 2 W's equal to 46. And what can I use to relate all three of these sides, the length, the width, and the number 17? If you said Pythagoras, congratulations. L squared plus W squared equals to 17 squared, which is 289. Okay. So these are your two equations. You go ahead and try to solve. I'm going to solve by substitution. I'm actually going to solve for w in this case. So 2w equals to 46 minus 2l. I'm going to solve for w, and I'm going to divide everything by 2. So w just equals to 23 minus l. Going to take that and substitute it into our second equation now. So we get l squared plus 23 minus l all squared equals to 289. L squared plus, what's 23 squared? Too tired right now. Let's go to your graphing calculator or calculator. 23, 23. Oh yes, 529. I should have remembered that. 46L plus L squared equals to 289. We will collect like terms, so 2L squared minus 46L. And 529 minus 289 gives us 240 equals to 0. Remember, you're trying to solve for L. I think you can factor out a 2. L squared minus 23L plus 120. Think about what times what gives you 120 that adds to negative 23. I think it's 15 and 8. So L equals to 15 or L equals to 8. Now once again you need to solve for W, and we plug it back into the purple equation here. You'll see W equals to just 23 minus 15, which is 8, and the corresponding 8 here, 23 minus 8 equals to 15. They're interchangeable. So finally, I'll say the width, usually it's the smaller one, so is 8 centimeters, while the width, the length is 15. Okay. Alright, ladies and gentlemen, so try number 3 now. Once again, you're solving systems of equations. This time it's a quadratic and a quadratic because you see both equations have a square. Quadratic, quadratic. Okay? But algebraically, it's the same methods as before, so I'm going to let you try this one out on your own. I won't be doing any talking out loud, so I'd like you to try both substitution and elimination, and then try it on your own. Pause the video. Once you're done, come back and let's see what your answers are and if they match mine. Okay? Go ahead. Try on your own. Okay, ladies and gentlemen, so I hope you tried both ways. I know you got some nasty things here, but don't forget, if you can't factor, always go back to using the quadratic formula. And also, don't forget to simplify. This is the chapter 5 stuff now, remember? Root 20, that's the same thing as 4 times 5, and that's the same thing as root 4, root 5, 2 root 5. So once again, lots of review taking place in these later chapters in the Math 11 curriculum. Okay? Anyways, there are the answers down there. All right, let's turn the page. Solve these systems of equations algebraically, and once again, you can do whatever you wish. Okay? Uh, 2 questions here, and then afterwards, just another word problem. Okay? I'm going to let you try these 2 on your own. Well, maybe at least the first one. I'll give you a hint for the second one because you got those fractions, nasty fractions. But nonetheless, for A, you should be able to do. Okay, so try please on your own. Notice how I'm using elimination for this one, and I'm lining up all the terms underneath. I just find that a little bit nicer to deal with. And then it's easier for me to decide if I should add or subtract. I think in this case I will subtract. So we have 5x squared minus 40x equals to negative 80, I believe. 5228, yep. We'll bring all the terms to one side, and I see that there's a factor of 5. Let's do that. 80 divided by 5 is 16. This is cool because when you solve and factor, this just becomes 2 of the same thing, and therefore you only have one value of x, that's just 4. Which is nice because now when I try to solve for y, there'll only be one answer. Which equation would you like to use? It doesn't matter. I'll use the first one. Okay, since they're both, I think, relatively the same in terms of difficulty. 4 squared is 16 times 3 is 48. 24 times 4 is 96. 48 minus 96, that's negative 48. Add to the other side, becomes positive 48. Positive 48 minus 52, that's negative 4. So I believe y equals to 4. Well, look at that. Double 4. And only one solution. Done. Okay, looking at the next one here for B, I know there's that dreaded fractions. Oh, nasty, nasty, nasty. If you don't like fractions, we can try to clear the denominator by multiplying each term by the particular common denominator. Once again, when you do that, it won't change your solution. It'll change how the equation looks like, but it won't change the solution. What's more important here is really the solution. So I would suggest us multiplying everything by 4 in the first equation. 4 over 2 is 2, so 2m squared plus 4 over 4 is just 1, that's m. 4 divided by 2 is 2, so that's negative 2n equals to 12. And I think for the one underneath, I will multiply by, let's say, 12. 12 over 3 is 4, so 4m squared. 12 divided by 4 is 3, so that's minus 9m. 12 divided by 6 is 2, so that's plus 2n. I'm going to move this to the side just to keep it the same. So negative 1/3 times 12 would be equal to negative 4. This is nice. I will use elimination once again because I can definitely eliminate n right away. So I'm going to add equations together. Gives us 6m squared. M plus negative 9 is negative 8m. And this equals to, I believe, 8. Move everything to one side. Lots of factoring again. Maybe I'll factor the factor of 2, 3m squared minus 4m minus 4. Okay. If you like to factor, you can use choose method, finding two numbers that multiply to 12 and add to negative 4. Any possibilities here? How about 6 and 2? Someone suggested. Sure. How about negative 6 and positive 2? Even better. M minus 6, M plus 2. Be careful, don't forget to divide by that A value. So we have M minus 2, 3M plus 2 equals to 0. Two values for M equals to 2. M also equals to negative 2/3. You think all that hard work is done, but you're not. There's more to do. You have to plug it back into one of the equations. Don't know which one you like? I'll take the first one again. Okay. Actually, 1, 2, 3, 4, all of them work. So I'm just going to use that purple one that's on the top. That just looks better to me. Okay. 2 squared, 4 times 2 is 8, plus 2 is 10. So 10 minus 2n equals to 12. Negative 2n equals to 2, n equals to negative 1. That's pretty nice. So 2 comma negative 1. Okay. By the way, if you're not too sure which one comes first, well, write down a bracket like this, m comma n, and that shows that your m value is the first value, your n value is the second value. In the previous ones, x and y, we always assume that x is the first. Okay. Doing the same for this one, negative 2/3 all squared plus negative 2/3 minus 2n equals to 12. That's 4/9. 4 times 2 is 8. That's 8/9 minus 2/3. I'm going to change really quickly. 3 times 3 is 9. 2 times 3 is 6. Okay. I know I'm doing this fast, but you know what? Maybe you can figure this out yourself at home. You can always slow down and stop the video, right? Wow. 12 times 9. That's 108. Which means this is 106/9. And if I want to solve this, nasty, nasty, nasty. 1/6/9 times 1/2. Ooh, negative 53/9. Ooh, nasty. But nonetheless, also another answer. Done. Woo. Might want to give yourself a break before the next one. But I won't, because I'll chug along and we'll figure out the last one and then we'll be done for today. Okay? So please try these at home. Yes, they're long, yes, they're tedious, but you need some practice to do well. Okay? This one reviews a lot of stuff from chapter 3. Remember that vertex form of a parabola? I'll write it out for you again. The equation of a parabola in vertex form. Y equals to a bracket x minus p all squared plus q, where p comma q was the vertex. Don't know if you remember that. You should. Once again, good review for your final exam at the end in June. Well, the first part says a parabola has vertex 3, -1, and passes through this point. So let's find the equation of that first parabola. Okay, y equals to a. Let's substitute in the 3 and -1. So x minus 3 all squared minus 1. And to solve for a, I'm going to plug in the point. Okay, plug in the point 1, 7. So 7 equals to a. 1 minus 3 is -2 all squared minus 1. 8 equals to 4a. A equals to 2. And lovely, 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 because we now have an equation. Once again, that's not the only one, because there's a second parabola. Vertex at 1, 4, so x minus 1 all squared plus 4. And since the y-intercept is 3, I'm going to plug in the coordinate 0, 3 this time. 3 equals to -1 squared plus 4. -1 equals to a. And therefore, in this case, we have y equals to -1, or negative, just x minus 1 all squared plus 4. Equation number 2. Okay. And I'm asking you for the approximate coordinates of the points at which these parabolas intersect. So if you want to intersect them, you have to make them equal each other. That means you want to now solve the system, and I'll call it the quadratic system, because two equations, two variables, system of equations. Since they both equal to y, I'm going to use substitution. And then we have 2 bracket x minus 3 all squared minus 1 equal to negative bracket x minus 1 all squared plus 4. Go ahead and try to solve this now. X squared minus 6x plus 9. 2x squared minus 12x plus 17. This side, I'm going to expand this out and be careful with that negative in front. That's going to be many of your downfalls. So just make sure you do things carefully and properly, and life will be good. We're going to group all the terms together on one side. I'm going to move everything to the right hand side so we get a positive 3x squared. I see you're going to have a minus 14x. 17 plus 1 is 18, minus 4 is 14. And I think we're going to have to factor again. Two numbers that multiply to 14. Oops, sorry, not 14, 42. Sorry, 3 times 14 is 42. Add to negative 14. Oh boy. 6 and 7. 21 and 2, 14, 3. I don't think anything works. Time, of course, once again, to use the quadratic formula. Sing the song if you wish, or if not, just write down x equals to negative b. By the way, here's your a value, b value, c value. So there's my negative b, so negative of negative 14, plus or minus b squared, that's negative 14 squared, minus 4 times 3 times 14, all over 2 times 3. Yikes, nasty. 4 times 3 is 12, times 4 is 168. Whoa. Okay, I think we're getting decimals here. 196 minus 168. Oh yeah, root 28. That's about 5.29. Add to that 14, divide by 6. How about one answer for x of 3.215? And another answer for x, taking the negative 1, 196 minus 168. Square root of 168, make it negative, add it to 14, now divide by 6, 1.451. Okay. Don't forget you're still not done because you're solving a system of equations. You'll go ahead and solve for y. Plug it back into either the black one or the blue one, it doesn't matter. I'll put it into the black one, negative 3.215 minus 1, all squared, plus 4. So once again, you can't see what I'm doing. I'm plugging into there. That's the same thing. Let's get my calculator out. 3.215 minus 1. I'm going to square it. Put a negative in front. Add 4. Negative 0.906. 225. And similarly, if you do it to the other one, y equals to, go negative bracket 1.451. So this time I'm typing everything in all at once. Okay, plus 4, 3.797. So 3.797. So ultimately, please write your final answer as a coordinate pair. 3.215 goes with the negative 0.906. And then the other pair, which is the 1.451, that goes with the 3.797. And there you go. That's it for Chapter 8, by the way. Yes, Chapter 8 is now done. Expect a test coming up soon. Not next class, probably the next one after that. Make sure you go home, do some homework, and understand this stuff because your test is coming up fast.